First of all, I want to thank Serverlessconf for letting me talk to you guys today, and for all of you to come into my talk. I really appreciate it. My name is Rich Jones. I'm the founder and CTO, kind of head R&D guy at Gun.io. We help companies build awesome stuff. I'm also the author of the Zappa framework, which is the best damn serverless framework in the world. Sorry, Austin. Sorry, Florian. But today I'm here to talk to you about globally available serverless architectures. So what does that mean? What I'm talking about specifically is applications designed to run in multiple regions around the globe simultaneously. That sounds cool, you're thinking, but why would you want to do that? Let me tell you. Primarily is speed. So if you ping from New York, where I did this ping to US East 2, the new region that they just announced in Ohio, it's 40 milliseconds round trip, which isn't too bad. But if I ping Tokyo, then I get 200 milliseconds latency. So there's 200 milliseconds just for the round trip. Because the Earth is big. There's really not much that we can do about that until they change the speed of light, which they're probably working on. I'm sure Amazon's got something in store for that. So please, if you're in the US, provide all of your users around the globe with an equivalent service. If you really want to be, a big player in, the internet web space, you have to provide a globally consistent product. The number two reason you might want to have a globally available architecture is the scalability. So if you take the training wheels off of your Amazon account, you can probably do 5,000 to 10,000 simultaneous connections in one region per, for your Lambdas. But if you deploy that in all of the available Lambda regions, then you can, get 45,000 simultaneous connections, which, if you add it up, you're now dealing with T's, which is awesome. We're building products that can now scale to trillions of events a year, which is pretty cool. Another big one is redundancy, right? So as we sort of learned yesterday from Charity, cloud computing is still an act of faith, right? Like Amazon goes down to, you guys might remember last year, there was like a 5-hour outage where just none of the internet worked. If you're in the US, like couldn't date, couldn't watch Netflix, couldn't get a hotel, couldn't fuck off online. Like, it was terrible. It was like caveman type life. But Amazon goes down too, but generally it doesn't all go down. It's usually on a per region basis when Amazon goes down. So you want to fail over to, if one of the regions that you're operating in goes down, you want to have another region available so your web traffic is still up and your service doesn't go online without, your customers calling on you and screaming at you. Fourth reason you might want to do this is security. So one of the central components of your security model is going to be if you can compartmentalize your data, then you can limit the damage that happens if you're compromised in a single region, but there's no way to access the data in another region. Then at least you're not totally boned; you're only partially boned. It's an official term. Ask your CSO about it. So typically, when you're building your security policy for a serverless architecture, you're going to want to combine your corporate policy, like whatever your internal procedures are for your company, your cloud vendor security policy, probably IAM if you're on Amazon space, the virtual separation of your VPCs, and even the physical separation of your data as well. Like you may want to have air gap data, you may want to have a physical link that you get to Amazon from your data center. And then a big advantage of having a global security model is that you can defend against internal and external threats as well. So if you're a UK company, but you have a region in Asia, you may not want your Asian employees accessing the data that's available in the UK as well. Security is a big topic. I'm not saying that just by making your architecture global that you're making it more secure by default. In fact, you could be doing the opposite if you do it wrong, but it's just something that you really want to consider. Ask your neighbor's teenage son for more details. And the big one, this is that kind of led me to developing this talk and the features that you're going to see later is regulatory compliance as well. So different countries have different laws. This is a big one if you're dealing with medical data, for instance. So as we're going to see in a little bit, in the United States, there's a law called HIPAA. So there's a very strong medical privacy law, for instance. So you're not allowed to let medical data ever be unencrypted at rest or in motion. You're also not allowed to send it out of the country, which also applies to financial data. I haven't done as much fintech as I've done medical stuff, but PCI has similar compliance laws. I'm sure that there's European equivalents. Again, any kind of personally identifying information, if you're an EU company, you probably know more about this than I do, but there's the EU Privacy Directive, EU Data Protection Directive, sorry, that says that you can't send PII all around the globe without explicit consent. Even just private communications, like if you're building a chat app or an email client or something like that, if you're dealing with German customers, then you're not allowed to send their data outside the country without the right consents. Again, yeah, this is different in the United States and Europe, but here you have the EU Data Retention Directive, so you actually have to have a defined policy for your, you have to keep it for a minimum amount of time, but you also have a ceiling on that time, so you have to get rid of it after a certain period. But in the United States, there's basically no such equivalent unless you're in California, and then, so again, I'm not your lawyer. You don't want me to be your lawyer, but you should, if you have one, consult before you actually deploy some of this stuff globally. So yeah, basically to summarize, you will have one product, one code base, but you have different compliance needs in different countries. And you want to have a worldwide base of customers, but you also don't want to have a warrant out for your arrest in Germany. Okay, you're convinced, but can I see an example, you're thinking? Of course. So we're going to do 2 case studies today. Kind of a simple one that you can probably use right out of the box, and an advanced one that if your company is thinking about porting to a global architecture, just some things that you might want to consider. And we're going to use Zappa to deploy our trivial case at least. But what is Zappa? What is that? I didn't explain what that is. That's right. Let me explain that for you. Let's take a brief interlude and learn about Zappa. Zappa. Full disclosure, this is my baby. I've been working on this for the last 6 months, maybe even more than that now. It's a tool currently for AWS Lambda and API Gateway. I'm interested in adding other vendors, especially free software vendors on top of this, but currently it's a tool for Lambda and API Gateway. So it allows you to have all of the ops and scalability benefits of using Lambda technologies, but for your existing API applications. So you kind of all know this stuff. If you're Python people, this is the way that a traditional web server works. It's pretty basic. So you have a web server like Apache or Nginx that's just constantly listening for requests as they come in. After it comes in, that gets converted into WSGI or WSGI, which is this common interface that all Python web applications speak. It sends it to your WSGI server. That sends it to your custom application. Your application processes the request. It sends it back through the web server, and it goes back to listening. The obvious problem with this is that if you get a sudden spike of traffic and you're not prepared for it, the request queue starts to build up. So the requests that come in at the end time out, and people think that your website is down. So with the Zappa model, which uses Lambda and API Gateway, it uses the velocity template language, which is an abomination. I learned it so you don't have to, but it's basically a WSGI to the response you get from Amazon API Gateway, WSGI mapper and kind of middleware layer that you can wrap your existing web application in. So the server is created after it comes in through the API Gateway from the warm Lambda cache. It converts it into a WSGI request. Your app returns it. And then the server is destroyed before the thing even responds. And it only introduces about 30 milliseconds of overhead. So the time for the SSL handshake is the same time as the overhead for your function. this is just like the Zen thing about it. I like to think of it, rather than like permanent uptime, I think of it as like permanent downtime, because like most of the time your server isn't there, and I find that to be like a kind of calming. But this also comes with some immediate advantages that you already know about, so it's super scalable. Because one request is one server, it also means that, 10,000 requests is 10,000 of servers, and you can handle as many events as you need to. Generally, it's orders of magnitude less expensive because you're paying 0.000000002 dollars per millisecond, which I've converted to you for your convenience at point. You also get 3 million free seconds a year if you're on the free tier plan. If you know how to generate fake accounts for your custom Amazon deployments, that's unlimited free seconds, which is nice. So. Personally, before Zappa, I actually had 4 like DigitalOcean droplets I was just running all my personal projects on, and that ended up costing me like $1,000 a year just to host my own like personal side project stuff, and I converted that all to Zappa, and it's cost me nothing, so it like saved me $1,000 a year like right out of the box. So that's nice. The big one. Is that you don't need to modify your existing applications. So if you're already a Python web framework user, you can use this out of the box today. So it's super easy to get started with. There's no vendor lock-in. So if you're a developer or an engineer or whatever at your company and you want to start playing with serverless stuff, but your bosses, your CTO is going to hate vendor lock-in, this is a really good way to sell it because you can leave at any time. If you want to go back from, because it's all whiskey, if you want to go back to Iron or your Colo or Prem or whatever, like you can do it. Yeah, it works with any whiskey application out of the box. Here's a guy who did it. He's like, yeah, I didn't have to do anything. It just worked and I saved a bunch of money. It's Python only, which is a feature because Python is the best, and whoever came up with the idea of using JavaScript on the server side is a sociopath. I'm sorry that happened. It's really easy to start using. Once you've got it pip installed, Zappa init will take you through a nice like setup process. It'll automatically detect the type of application that you have, if it's Flask or Django or whatever. It'll configure that properly. It'll create your buckets, create all the policies for you. Then to deploy, it's just deploy. So it's really good for microservices. If you've got little Flask APIs or just like small APIs inside your company, you can port them and save a bunch of money right out of the box. It's good for IoT. It's good for chatbots. But you can run full Django on it. You can run a whole CMS out of Lambda if you want to. And there's a bunch of companies that are doing that now. So it works. It works great. But you still get all of the if you want to incorporate event-driven architectures into your existing web applications, you can still do that really easily. You just define in your configuration, you just define a path to the function that you want to execute and the event that you want to trigger on. It's just a regular expression there. You don't need to write any like custom handler code or anything like that. It'll just work. You also get the timed events. But wait, there's more. You get free SSL out of the box. Just by calling certify. It uses Let's Encrypt, so it's not even tied to Amazon's cert service. And because Lambda functions can be triggered from time, it'll create auto-renewing Let's Encrypt certificates. So you just get like free auto-renewing SSL forever out of the box with a single command. It's dope. It's also like pretty battle tested at this point, so you get like real common log format log tailing that you can that automatically dumps into your CloudTrail. You can use with your existing log management tools. You get rollback. It'll automatically keep the Lambda function warm, so you never get that annoying hit, that 10-second boot from cache hit that you get on non-warm or serverless framework functions, or on like Heroku and stuff like that. It works with VPCs out of the box. It works with we've pre-compiled and pre-packaged all these like popular scientific computing libraries. So it'll automatically, you don't have to, you can have your OS 10 developers deploy to your dev environments from their laptops using Linux compiled dependencies right out of the box. Right now there's about 15 in about in a week there'll be a couple hundreds because we just figured out a cool new way of doing it. You can load remote environment variables from S3, which is super handy if you're actually using this in production. So like you don't want to have your devs have access to your secrets, but you can load secrets from your Lambda. So if you have like secret database configurations and stuff like that that you don't want to expose, you can do that properly. I haven't counted how many factors it is yet. It might be 12. It's getting up there. It integrates nicely with your CDN, so all the commands that the output that it's going to give you is also available in a machine readable format. So you can respond accordingly to that. You can invoke commands. You can invoke raw Python if you want to check your. It's got some custom Django managements. You can use all different kinds of security. If you want to just use a simple API key, it's just a flag. If you want to use your IAM, it's just a flag. You can even define your own custom authorizers, which is nice, which also, again, is just a single function that you define inside of your application. That came from a PR pretty recently. Shout out to the Australian guy who contributed that. I appreciate it. Anyway, yeah, it's got a bunch of other stuff. I've gone on for long enough about it, but you should try it out. It's pretty awesome. Cool. Anyway, back to our case study. Let's build a globally available API microservice. Let's call it GeoBiz, because that sounds cool. I love the .biz domain. Geo's appropriate. So what we're going to do is we're going to build an application that just geolocates a user. That's all it does. It's a microservice. It's functionally useless, but it does one thing, and it does one thing pretty well. So we're going to return users latitude and longitude from the Maxmind Geo IP database in less than 200 milliseconds from anywhere in the world in 5 lines of code with 0 configuration. And you can follow along at home. After the talk, I'm going to publish this stuff to my GitHub. The way you use Zappa is it just packages up your Python virtual environment. So our server is pretty simple. It's a standard Flask application. This is the whole thing. You don't have to define the custom routes and API gateway. It'll just like handle that stuff automatically. It's a regular Flask app. It's a real simple. We're going to look up the IP address and we're going to return it. It's basic. We're going to call Zappa init, which brings you to this like nifty old school BBS style interactive setup wizard thing that'll help you automatically create your AWS environment. It'll do all that funky stuff so you don't have to. It's nice. You can set the domain, so we'll call it geo. That should be geo.biz, whatever. And then a new feature, kind of for this topic that I've wanted to work on it for a while, but this is new hotness, is do you want to make this a global application? Full disclosure, yeah, this is totally new. It's not battle tested, so you're at the cutting edge right now. Isn't that exciting? But after you run the wizard, you're going to get a nice configuration file that gives you all these different environments. And then to deploy, you can just tack on the all flag to deploy to all regions simultaneously, and then certify, get less encryption certificates for all of those domains. And then you're done. Bam! You now have a globally available API microservice, and we can look at HTTP stat on any of the endpoints that it'll generate, and you'll see that we'll typically get less than the 200 milliseconds that we were targeting. Cool, dope. But now you actually have to make a decision. So I've sort of glossed over some stuff, obviously about how to turn that into a real application. Like how do we actually route the web traffic for our users? And there's a bunch of different policies that we can choose from for actually delivering, our users through the DNS to the website that we want to use. So there's a bunch of different data centers, and they're all far away, and we want to make sure that the people are redirected to the right ones. So the first one that we can do, which is what we do out of the box right now, is simple, aka stupid, where we just map the region that we're going to in the URL directly. This is good for robots. So like if you have a backend service or something that's not being exposed to users, that you just have other bots, or other features or functions, whatever, in your architecture, and they need to know where to look. That's a good way to do it. So it's actually useful for robots, but it's obviously bad for humans because you're not going to tell your Chinese customers, oh, just go to like US or whatever, AP Northeast 2 my domain.tld, because that sucks. So another thing you can do instead is latency routing. So Route 53 will automatically route traffic to the net closest node that you've deployed to, which is really simple and smart, but and really good for just if that's your design decision is to provide the fastest service to those users. It's pretty good, but it's bad for compliance because you could end up in a situation if you're doing it by net net time, then you could end up routing your Australian users to China or vice versa or something like that. So to remedy that, you can instead do geolocation, where you actually try to geolocate the inbound IP address and turn that into a country code and then map that to your traffic. So if I get a USA address, I'll map it to US East 1, UK, Japan or whatever, so it's pretty cool. So that's probably, if you're building if you're designing for compliance, that's probably how you'll want to do it. But it's not as good for load balancing, because imagine if you have a huge spike in in the Australian region, then that one, you could topple that one over, but still have extra capacity in China or something like that. So if you're just designing for load, you can have a round robin, which will you can define a custom strategy out of the box. It'll just evenly distribute amongst all the available nodes, or you can say, we have a primary and then we have an overflow, so you can give a stronger weight to your primary, but then if send some to your overflow capacity as well. So it's good for balancing load. But you typically, because you could end up in a situation where you're actually routing traffic kind of the wrong way, if the round robin is kind of stupid, then you could actually send people to nodes that are further away when you don't want them to. So that's best. This is kind of a good strategy if you're doing it for like a national deployment, like multiple places in the US, where it's never going to be over the limit or something like that. So yeah, it's bad for lowering latency because you could accidentally route people to from the US to the Asian servers or something like that. Bonus, you can actually just slap CloudFront in front of any Zappa endpoint and then get it cached on your CDN, but obviously you don't want to do this for dynamic content, but it's good if you have landing pages or maps or about pages or something like that. And these are all pretty easy to set up. I haven't integrated this functionality into Zappa yet because it's pretty much just like you click in the console in Route 53. Let me know if you guys actually end up using any of this stuff, because Zappa's design goal is to cover the most common use case out of the box. So if there's one predominant use case that people end up using it for, I'll make that the default traffic policy and make everything else easier to configure. So, but I want feedback on that. But now you're like, okay, but that was a pretty easy example. I thought we were going to be building some serious event-driven serverless applications here. And yeah, okay, we will. So case study B, let's build a globally distributed medical service. So I actually did build something similar to this one. This is kind of, it's oversimplified obviously because we don't have very much time, but I built something like this in the wild. So yeah, with medical data, obviously, medical and financial data, you have to be super, super careful. So let's describe kind of the process that you'd use Lambda in a medical or scientific environment for. So you take the data from the endpoint of the hospital or wherever. We're going to process it in some way. We probably have some big beefy GPU instances that are transforming our data. We would then want to store the results of our medical processes and then notify the recipients that hey, your test result is ready pretty much. We'll call it Medico, because that sounds like a billion-dollar name to me. Buzzer alert, we're going to call this a hybrid architecture. This is a term I've been using a lot lately to mean we're going to be using HTTP and non-HTTP event sources, and we're also going to have permanent and non-permanent infrastructure. So our HTTP event sources will be stuff like API calls, the user pages, dashboards, all that kind of stuff, results pages. But then under the hood, we're going to have the files, we're going to have queues, we're going to have notifications. we're going to use API Gateway, we're going to use Lambda, SQS, SNS or SES, and then have our big beefy machines in an auto-scaling group so we can do the appropriate amount of processing on our data as it comes in, but scale accordingly so we don't end up breaking the bank when there's no information coming in. So the process will be typically it'll upload the medical data to the bucket. That'll trigger your Lambda function. Your Lambda function will probably put something on the queue. Your EC2 machine will then pick that up off of the queue, crunch the data. Once the data is crunched, it'll put that back on the S3. The S3 will call the Lambda. The Lambda will notify the doctor that the result is ready. And yeah, then the patient gets their result. But I thought there was going to be a hybrid architecture here. What's missing? Yeah, I lied. The elephant in the room, of course, is data, right? Like, if you're building a real production application, you're gonna need a database. Like, we've seen a lot of examples of kind of toy serverless applications that don't have databases. But if you're in a real business environment, especially if you've got auditing requirements, all that stuff, you're gonna need a database. So how can we build a database, a globally available database-backed application in a serverless fashion that's still performant, still secure, and still compliant with the regulations that we're dealing with? You're gonna need a few. You can't have one big database instance that's running in your main region anymore. You're gonna need to manage a few different databases with different properties. The magic bullet here is an Amazon feature that they provide called the read replica. So what you're going to do is you're going to have one primary that is kind of the master source of truth, and then regional replications that'll happen automatically through the magic of Amazon and SQL that'll copy read-only versions of your primary database to your local regions, because reads are fast. So most of the time you want to access the data, and you want that to be fast because that means page loads and stuff like that. Writes are slow because they're still going to go back to the original region, but typically you can make those asynchronous, so if you have a JavaScript thing or something like that, you can put it behind a spinny or whatever you want to do. So you can do asynchronous writes. They're slow, but it doesn't matter if you design your product right. So in our example, we'll still put our US East 1 as our primary, and in that we're going to store stuff like accounts, and aggregate data and anonymized data about what's going on. And then we're going to replicate that to our UK deployment or where else we're deploying to. So when users log in, they hit the read-only, and it's it loads quickly. They don't have to go across the ocean twice just to log into a website. But then and then that's going to store the replicated information. But then we're also going to have a local database server that's only accessible inside of that region as well. So the US people can't access the medical data of UK customers. So that'll store our encrypted medical data. And the cool thing about this is we can actually do this on a per table basis. So yeah, keep the user ID rights there, but then read them from the replica, for instance, and then make all of our writes and reads both to the local DB. If you're using Django, which you can do now because of Zappa, you can use existing web framework niceties out of the box. You don't have to write your own database router. You can use Django's built-in database router to handle this in your ORM just out of the box. So it's a little bit of configuration, tiny little bit of class creation, and then a little bit more configuration to use it, but then you're kind of done. So that's nice. Heads up, if you're using, you might want to use the same pattern for your schemaless data, but currently you shouldn't really do that because what they're offering is snapshot copy across regions, which isn't the same as a replica. You can't use it in a live fashion. It's just for backups, really. So I would strongly recommend using that. And in fact, RDS is actually pretty sweet as a schemaless data store on its own. So yeah, watch out for that. Yeah, it pretty much only works with MySQL, Postgres, or Amazon's proprietary MySQL variant called Aurora. So don't try to use it for Dynamo or anything like that. Another warning, there's still a loose elephant in the room, which is the VPC. The VPC configuration is really too complex for me to go into like too much detail right now, but I'll make you aware of some of the design decisions that you need to know about. Basically, the question is, what are you optimizing for in this case? Like, are you optimizing for compliance and simplicity, or because in that case, you kind of want to just minimize the number of VPCs that you have. But if you're trying to maximally compartmentalize your data, then you actually want to have like as narrowly defined VPCs as you can, and you may even want to have different, like completely different accounts and credentials for the different like regions if you're operating in that way. But even better than worrying about that is try to use the serverless paradigm as much as you can, and actually just try to avoid using any of this permanent infrastructure whatsoever. So like, do you need a database? Can you use a queue for that in this situation? Like, for instance, if you're probably using Lambda for a data processing pipeline, like can you keep your encrypted information in a secure S3 bucket instead, and then use cross-region replication to handle it that way? You know, this all depends on your traffic and like load and product requirements, but those are definitely things to consider when you're doing your initial architecture. As an example of something like this, that's kind of a neat serverless thing. I wrote a BitTorrent tracker using Zappa. It's like, you know, maybe 100 lines of Flask or something like that can handle millions of peers out of the box if deployed globally. So like bigger than the Pirate Bay and OpenTracker and all those combined, actually. But it doesn't even have any permanent database because BitTorrent traffic is so sparse that you can actually use S3 as a data store. It doesn't have to be like a real-time thing. If there's a you know, if it takes two seconds to do an announce, that doesn't really matter if you're able to run the largest BitTorrent tracker in the world for, you know, a couple of dollars. That's the kind of trade-off that you should be considering when you talk about these things. But if you're gonna replace your database, remember to log everything. You know, you're gonna have accountability auditing requirements, and make sure that you know how to read those logs before something goes wrong. Like have a fire drill about backing up your data and do it. Investigating your logs, like imagining that there's an intrusion event, do some chaos engineering as we learned yesterday as well. So to kind of wrap it up, save time and money, build awesome global applications, and use Zappa. Some of your favorite companies are, some of the people in this room are using it, at least they've told me that, or you could hire me to build them for you. If you want to contribute, it's totally free and open source, it's on GitHub. We also have a super active Slack channel with some of like the smartest people in the world working on this stuff. Shout out to the Slack channel when you watch this online. Really appreciate all your guys' support and even the lurkers. What's up? You can tweet at me, tweet at the company gun.io. Check us out if you're looking to hire awesome global teams of open source developers. Yeah, thank you.